We'll look now at dividing by complex numbers, which is a task in and of itself. It is even more complicated than multiplying them, but there is one important rule to follow when doing this. So let's take a look. In order to divide by complex numbers, it's important to consider a special notion that exists for complex numbers but not for real numbers, which is something called the conjugate or the complex conjugate. And what I do to compute this is I take a plus bi, which is a general complex number, and I switch the sign of the imaginary part. So for example, the complex conjugate of 1 minus 2i is simply 1 plus 2i. I leave the real part alone and switch the sign on the imaginary part. So why introduce this notion for dividing complex numbers? Well, what it lets me do is efficiently clear the denominator of a complex fraction. We can look at the following general example here. If I have a plus bi divided by c plus di, what I'd like to do is remove the imaginary part here. One way to do this is to multiply both the top and the bottom of the fraction by the complex conjugate of the denominator. So I'll say multiply top and bottom by c plus di bar, the conjugate, which is c minus di. And if I do this and keep track of my computations correctly, I end up with a complex number on top and a real number on the bottom. So I remove the division by a complex number, and I just get division by a real number, which I know how to do. So let's look at a few examples illustrating how multiplying top and bottom by a complex conjugate can help us simplify a complex fraction. So let's look first at 1 divided by I plus 1. So to clear this, I multiply top and bottom by the complex conjugate. So this is minus I plus 1. And the denominator becomes negative I squared plus 1. So minus I plus 1 on top and 2 on the bottom. So there's no longer any imaginary part on the bottom. Here we play the same game. I multiply by the complex conjugate, so minus 3i plus 2. On top, I have to pay attention and expand this out correctly. So this is minus 6i squared plus 6i plus 3i minus 2. And downstairs I have minus 9i squared plus 4. So this ultimately gives me 9i minus 6i squared is 6 plus 4 divided by 13. So again, by multiplying by the complex conjugate of the denominator, I clear out the imaginary part of the denominator. The last example is somewhat simpler. So I get minus 4i plus 8 on top, and downstairs I get minus 4i squared plus 16. So minus 4i plus 8 divided by 20. And if you like, you can simplify this to minus I plus 2 over 5 by dividing out the 4's. So it is possible to divide complex numbers, but you have to be careful. You have to make sure that you clear out the denominator by multiplying by the complex conjugate so that you have something that does not have division by something imaginary.